Okay, this is an example in which a rancher is building a corral. He wants to make it one big rectangle with 3 identical rectangles within it. 528 feet of fencing to build the outside and the borders in between the 3 rectangles. So that means all the fencing around the outside and this border and that border. All that is the 528 feet of fencing. He wants to build the rectangles in such a way as to maximize the amount of area. He wants to make the space inside as maximum, as much as possible. Of course, that makes sense. So this is a very practical question. These kinds of questions, not just for ranchers, but for all kinds of real-life industries where you want to maximize the space of a storage silo or a shipping container or all kinds of times in life. This is a needed and desired thing. So very practical question here. How do we go about this? Well, we're going to need to call each of these X. We don't know what they are. They're all the same. All these are the same, so I'm using the same letter. I don't know what those are, what the width of each of those little corral sections is going to be. Call it X. And then the other dimension, this, call these guys Y. I don't know what they are. They're all the same as each other, but they're different than the X's. So I use a different letter. Those are the variables. Okay, so then we're going to have 2 formulas. The first one is the fencing, 528 feet of fencing. So 528 feet of fencing is going to be, what do we got? 6x and 4y, right? 1, 2, 3, 4, 5, 6 x pieces and 1, 2, 3, 4 y pieces add up to be all the fencing, the 528 feet of fencing. 6x plus 4y. That's our first equation. That's the fencing equation. Now our second equation is going to be what we're trying to maximize. We're trying to maximize the area. And what's the area? Well, the area of this piece is x times y, right? It's just one side times the other. X times y, that's the area in there. This one is also x times y, and this one is also x times y. So the total area is xy plus xy plus xy, better known as 3xy. So that's the maximum, that's the area we're trying to maximize, 3xy. Okay, so how do we do this? How do we go about this? Step 1, solve your first equation for y. So I'm going to take, you could solve for x or y, it doesn't really matter. I'm going to take that first equation and I'm going to solve, because I basically want to get this guy to only be one equation in a minute, one letter in a minute. So let me take this 528 is 6x plus 4y, and I'm going to solve for y. So here we go. So subtract the 6x from both sides. 528 minus 6x is 4y. Then divide through by 4. So y equals, I'll use my calculator, 528 divided by 4, getting 132 minus, and this will be 1.5x. Okay, so step 1, solve the first equation for y. We did it. Step 2, plug y into the max equation. So I'm going to take that max equation, which is right here, and I'm going to plug in. So it says max area 3xy. I'm going to take this right here and plug in for y. So what do we get? 3x times y, which is 132 minus 1.5x. Let me go back here. Oops, and do a better job of making sure we can see that 132. There we go. So the area, distribute this, use your calculator. What's that going to be? 396x minus 4.5 x squared. I like to rewrite it to put the the x squared term in the front. Just I think it's easier. You don't have to. So there we go. Now we're trying to maximize that area. And you know that's a parabola, huh? If we were to graph that thing, it would be a U shape, a parabola. And the maximum would be the vertex, the center of the parabola. Right? Because this is an x squared equation with a negative in the front. So that means it's a U shape going down. It's a parabola going down. So to find the maximum, you find the vertex. And the x value of the vertex, I hope you know the formula, it's negative b over 2a. Important formula to have on your notes for the exam. So negative b over 2a. What's a and b? Well, this right here is a. It's the number in front of x squared. This is b. So a and b are the numbers in front of x squared and x. They're not the x's themselves, just the numbers in front. So what do we get then? We get negative b, 396, over 2 times a, and a is negative 4.5. So if you simplify this, you get negative 396 over negative 9. Divide that on your calculator. I'm going to do that too. 396 divided by 9. I'm getting 44. That's nice. X is a nice clean 44. And now let's go back and get y. We have a formula back up here for y. There it is. Y is 132 minus 1.5x. Y is 132 minus 1.5x. Grab this, plug it in there for x, and we'll get y. 132 minus 1.5 times 44. Use your calculator. I'm doing mine right now. I'm getting 66. So y is 66. So that is going to be the best way for the rancher to build the corral. Let's take that back up. 44 and 66 for x and y. 44 and 66. So this x should be 44, 44, 44. And the y should be 66, 66. That's the best way to build it to get maximum area. So the shorter side is this, of the whole rectangle is this. This is the shorter side. And the longer side of the whole rectangle, all three parts. So that means this longer side here is whatever 3 times 44 is. What's that? 120 and 12, 132, I think. And what's the total area? Well, each of these rectangles is 66 by 44, right? So it's 66 by 44, and then that's times 3 because there's 3 rectangles. So let's use my calculator. 66 times 44 times 3. I'm getting 8712. Total area inside for the corral. So there we go. So on these problems, we set up with x's and y's, the various dimensions. We write 2 formulas, one for total fencing, one for area we're trying to maximize. We solve the first equation for y. And you got it here, and then we plug that into the maximum equation. We get something that has only x, and then we can find the maximum knowing that that's a parabola. It's an upside down U shape. The vertex, the maximum, is negative b, x equals negative b over 2a. Plug that in, find x, plug back in, find y, and we've got it.